Alright, ladies and gentlemen, welcome to our second lesson on rational expressions. Today we're going to be looking at multiplying and dividing rational expressions, and to get started I just want to talk about fractions for a moment. Remember that a rational expression is written in fraction form, except we have a polynomial in the numerator and the denominator. End result is that anything that we can do with fractions we can do with our rational expressions. Shouldn't do that. So let's take a look at these two guys for a second, just as a quick review. Remember that when we have two fractions and we are multiplying them, we multiply the numerators together and we multiply the denominators together. Once we have that, we also have the opportunity to start doing some canceling or some simplifying. So I can take a 7 out of there and get 1, and a 7 out of there and get 4. I can take a 4 out of there and a 4 out of there and get 1 and 3. And that leaves me with 1 times 3 in the numerator and 8 times 1 in the denominator, which of course is 3/8. Now, when we divide, remember we take the reciprocal of the fraction doing the dividing, and we multiply. So the reciprocal of 16 over 25 is 25 over 16. And then I'm back to the point where I'm multiplying again. I do the numerators and the denominators, and I can start simplifying. 5 goes into that once, and into that 5 times. 4 goes into that 3, and into that 4 times. And that leaves me with 3 times 5 over 1 times 4, or 15 over 4. Now, let's apply this to our rational expressions. Here's two monomials, just like we started yesterday in the last lesson. And in this case, I'm multiplying them. I'm going to take the monomial in the first guy, and I'm going to multiply them by the monomial in the second fraction. And all of that goes over 7ac times 8bc. At this point in time, you could start simplifying. If you wanted to, you could write this out in long form: 14 times b times c times 12 times a times c. If that helps you, feel free to do it. There's absolutely no harm in doing it. Not a necessary step if you can see where you are going to be able to cancel. But I do find that it helps avoid unnecessary errors if you do it this way. So if you can get a better mark, you might as well do it. And we can keep on canceling. And we have an 8 going into there, 4 and 3. Oh, and those 2's can cancel. Oh, and we have some A's there. And the C's, would you look at that? By the time we're done, in the numerator we have 3, and in the denominator we have 1. Final answer of 3. Oh, no, wait, I missed something, didn't I? I missed an A right there, so that should make that 3A, 3A. So that's our final answer. So not that different from what we were doing in our last lesson, where we were just simplifying or reducing these rational expressions. The only difference is we have this multiplication sign in the middle. Let's see what happens with some other examples here. Now, before we start, I want you to remember a couple of things. Once we look at examples that have binomials or trinomials, we're going to start seeing addition and subtraction signs. Remember that if we see an addition or subtraction sign in a binomial or a trinomial, we can only cancel out the full or complete polynomial from within the rational expression. We cannot cancel the individual terms that are separated with those addition and subtraction signs. We cannot cancel them from within a polynomial. So keep that in mind, please, as we are doing it. If you had something like 3b onto b minus 4 and b plus 2 onto b minus 4, the only thing that we can cancel in this situation is the entire binomial b minus 4. In order to simplify this, please remember that we cannot start doing things like this and cancel out the b's. That would be incorrect. So end result is, for this guy, let's erase that, we would be left with 3b over b plus 2. Okay, so please remember that. Remember about the addition and subtraction signs. That's really important. All right, so, whoa, that looks big and scary, doesn't it? But remember that as we start to simplify these rational expressions, we're going to start by factoring. So when you see something like this, I'm going to start by factoring this n squared minus 6n plus 9. And I can factor that down into n minus 3 and n minus 3, all over n minus 3. That's going to be multiplied onto 2n plus 5 over n minus 3 cubed. And at this point in time, if you wanted to start doing some simplifying, you could, or you could write it out in long form if you wanted to. If we wrote it out in long form, I'll do that quickly. We'd have this. Remember, that's just multiplication inside all of those. And n minus 3 times this n minus 3 cubed is just going to be n minus 3 written out 3 times. And I can do my simplifying where I'm taking out the entire terms, or probably the entire binomials, and I'm left with 2n plus 5 over n minus 3 times n minus 3. If you wanted to, you could write that as 2n plus 5 over n minus 3 squared. All right, so it looked a little bit scary when you first saw this big, massive expression. But remember that we start by simplifying. Once we simplify, we can take a look at reducing. And once we've reduced, then we can get a final answer. All right, let's look at a quick division. So remember that when we divide, we are going to inverse and we are going to multiply. So I'm going to switch that to multiplication and put the 3b plus 12, 6b minus 12. There we go. And now I can do some factoring. So b minus 2, b plus 2. This is going to be 3 onto b plus 4. Oh, I did a typo there, didn't I? That's supposed to be a 4. And that's supposed to be a 4. Hate it when I do that. Sorry about that. And 3 onto... Oh, pardon me, not 3. Wow, I'm not doing well today. 6 onto b minus 2. Okay, did I get that all right? Quick check. Yes, I did. All right. So now I can cancel out whole binomials and entire binomials there. And heck, I can even cancel a 3 into there, and I am left with 1 over 2. All right, so, similar process. I'm dividing, so I take the inverse and multiply, factor, simplify. All right, now this one's a little bit different. This first one looks like just a binomial, doesn't look like a rational expression. But remember, if I had something like this, that's the same thing as 2 over 1, which is 2 written as a fraction. So I could write this d minus 3 over 1 to keep that as a fraction. And I would have d minus 3 over 1 times, let's factor that guy, 3 onto d minus 3. And let's factor this bottom, d minus 3 onto d minus 3. And I can start canceling out like crazy. And I'm left with 3 over 1, which is 3. Okay, so again, we're living by the rules that you can do everything that you can do with fractions, with these rational expressions. So if you see something like this, you can put it over a 1 to turn it into a fraction form, and continue on. Okay, here's our last example of the day. This one's big and scary. But if you look at it, it's actually not. I'm going to start factoring all of these different parts. So here's the first guy I'm going to factor. I'm going to start by pulling out a negative 1. When I do that, I'm basically just reversing the signs on all of these. If I distributed that negative 1 back in, I would get back to my negative m squared minus 3m minus 2. And I've got m squared plus 8m plus 15 times 4m plus 20 over m squared plus 2m. And let's start factoring now. Minus 1. What does that trinomial become? Well, that's going to be m plus 2, m plus 1. This bottom trinomial, that looks to me like m plus 3, m plus 5. Multiply that onto 4 onto m plus 5. And this guy is going to be m onto m plus 2. Now, let's do some canceling. That goes, that goes, that goes, and that goes. And that leaves me with negative 1 times 4 times m plus 1 all over m times m plus 3. So ultimately that's negative 4 onto m plus 1. And, oops, I should have a bracket there. I'm going to leave that in its factored form. And that would be our final answer. Alright, so that is our last example of the lesson. Multiplying and dividing is relatively straightforward. It's just like working with fractions. All of the same rules apply. Keep that in mind, please, and take good notes and ask questions if you have them. Thank you very much.